Okay guys, today we're going to talk about our second transformation, which is rotation. Rotation can go at any angle around a central point. And it can go clockwise, meaning in the same direction as the hands of a clock move, or counterclockwise, which is the opposite direction. We're going to look at 90-degree clockwise around the origin, 90-degree counterclockwise around the origin, and 180 degrees around the origin, and see what happens. So if you take an image which has, a pre-image, which has a coordinate point at -3, -1, it rotates, if you're rotating 90 degrees clockwise, to -1, +3. The next point at -4, +3, rotates to +3, +4. This point is nice and easy because it's on the axis. It's at 0, 4, and it goes to 4, 0. And likewise, D is right on the axis, which makes it easy. It goes from -1, 0 to 0, 1. Okay, so if you look at what's happening, the X values are becoming the new Y values, but flipping their sign, whereas the Y values are going straight into the new X values without changing their signs. So the Y values go into the X values, so I'm just going to put a Y right there for the rule. So my new X value is always my old Y value. My new Y value is always equal to the opposite of my old X value. So I'm going to change the sign. So I'm going to put -X right here. So this is my general rule for rotating 90 degrees clockwise. Counterclockwise is very similar. I'll just do a few of the points here. This one starts off -3, -1. This time it goes to 1, -3. And I think you'll be able to convince yourself pretty quickly that we have a similar pattern that we can keep track of here. Oops. -3, -4. Okay, so let's look at what's happening here. The X values are going completely unchanged into the Y values. Okay, so my new Y values are equal to my old X values. The old Y values are changing sign and going into the X values. So here I have my general rule for rotating counterclockwise by 90 degrees around the origin. 180 degrees is even easier, because you can see if we take a point that's right on the y-axis, it stays on the y-axis, it just changes sign. Same thing with a point that's right on the x-axis. It stays there, it just changes sign. And in fact, any of these points, if you look at them, the x and the y values stay the same, but change sign. So the point at -3, -1 goes to 3, 1. And the general rule is x changes sign and goes into the new x, and y changes sign and goes into the new y. So there I have my general rule. Okay, so let's take that. We know for rotation 180 degrees, my rule is xy goes to -x, -y. So what's happening is each one of these points rotates 180 degrees around, and just changes the sign of both x and y. So if this is at -5, -3, it's going to come to 5, 3. And this is my new J prime. My H prime, if I start at -3, -5, well, it's going to come here to 3. Oh dear. There we go. I'm so sorry. Come to 3, +5. That is my H prime. So I can simply connect my dots, and I'm done. Okay, if I'm going clockwise, let's take this point right here. This is at -1, 3. It's going to go to +3, +1. Because remember, my rule for 90 degrees clockwise is x, y. My y's go into my x's, and my x's flip sign and go into my y's. So that's my f prime. My b is going to go from -5, 1 to 1, +5. H is going to go from -1, -2 to -2, +1. And finally, M is going to go from -4, -2 to -2, +4. And you can see that the relationships between these points also stay the same. So, for instance, M and H are 3 units apart horizontally, and now M prime and H prime are 3 units apart vertically because they have been rotated. Now you'd give it a try.